Greetings and welcome to Mr. Van Loo's poorly monetized low-budget science channel. Do not click subscribe. Okay, today we're going to analyze projectile motion with Logger Pro, and I'm going to show you how to include uncertainty for both the X and Y axes. So let's jump into it. First thing you need to do is insert a video into Logger Pro, and the way that you do that is by going to the Insert pull-down menu and going to Movie, and then select the video that you want to play with. You'll note here there's a scroll bar down at the bottom, and that's going to be useful. And you can also advance frame by frame by using these two little buttons down here. Okay, so the first thing that we need to do here is set up our video. So the way that we do that is by clicking on these three little dots here with the arrow, and we'll want to initially set our origin. So the origin is where our ball is going to pop out. In this case, I have a video of a cotton ball, and we'll set the origin as this point right here. Okay, so this is where the ball will be launching from. Okay, the next thing we need to do is rotate our axis so that it's parallel with the meter stick, ideally. Okay, so there we go. There's our origin set. The next thing we need to do is set the scale here, and the way that we do that is by clicking on this little ruler guy directly below the origin button. So click that little ruler guy, and then we'll pick the corner of my meter stick and just drag it over to the other corner. And then that will be a distance of 1 meter. Okay. If you were using a different length scale, that would be fine. You would just need to change this setting to the length of that scale. Okay. So now we are ready to start collecting data points. So we will scroll over until our projectile is in motion. And the first thing you're going to notice here is that we have a problem. So you'll note that my projectile is actually blurring. Okay, you can see the cotton ball has now formed this straight line. If you have a really good high-speed camera, you're going to see this effect less, particularly in good lighting. But here I've got a camera that doesn't have a great frame rate, and the lighting is not fantastic, and we've got this long blur here. So that's a problem, but we can deal with it. So the first thing I'm going to do is start placing dots. Okay, so we click the little red dot here with the crosshairs. And then we will place our dots in the middle of our blur. So that's our first step. So go ahead and do that. And I'm going to do this for all the frames, so I may need to speed up the video here a little bit. Yeah, I don't normally edit these, but it had to be done. This is much faster. Okay, so there are all of our dots. And now we're going to just back up here a little bit, because I need to measure some lengths. As I said, we want to deal with uncertainty here, and the way that we're going to show uncertainty is with error bars on our, I might just rotate this slightly. The way that we're going to show uncertainty is with error bars on our graph. And we'll take a look at that in a second. So what I'm going to do here then is try to measure this vertical distance from this corner to the midpoint, or the dot. And what I'm going to do is I'm going to make a right triangle. So I'm going to collect two measurements for each data point. Okay, so this is our measuring tool right here. And so what I'm going to do is draw a line from here, from the tip of my blur, and then I'm going to make another measurement from the center over. And what this is going to do is make a little right triangle. It doesn't have to be a perfect triangle. And in fact, I'd be a little surprised if it was. This is not perfect. We're estimating our uncertainty, okay? So don't get too caught up in the details here. Okay, what I'm going to do now is create a couple of new columns, okay? So right here, we'll go to Data, and we'll go to New Manual Column, and we're going to call this column X Uncertainty. And the unit here will be meters, okay? And then we will repeat that process, and we will add one more manual column, and we'll call this Y Uncertainty. And we'll call it YUnc for short. The unit, again, is meters. Okay. So these are our two columns, and over here on my video, it turns out that we have two measurements. We have one measurement for the X uncertainty and one measurement for the Y uncertainty. So we're going to go ahead and plug those in. Remember, for uncertainty, you can round off to the nearest single significant figure. So my 0.04903 is just going to become 0.05, and that's fine, okay? Remember, we are making an estimate. So there's 0.05, and then this will become 0.07, so I'll plug that in for Y uncertainty. Okay, so I'm now going to repeat this process for all my data points. It's going to be a bit time consuming, so I will speed up the video for that, and we'll take a look at the results here in a moment. Hey, so I've compressed about 20 minutes of clicking and dragging into a much shorter amount of time. If you are in a time crunch, you may want to check out a separate video in which I use a technique that's going to produce larger error bars, but should be also much faster. So there you go. Okay, well, that was fun. Really fun. I didn't say this was easy or not time consuming. Okay, so let's take a look at our data here. So what we have here is time on the x-axis, and we have both the x and y values on the y-axis, okay? Somewhat confusingly. So what we see here, if you look carefully, is on the x-axis, our object is traveling at more or less a constant velocity. This should be a straight line in theory. As you can see, we have a slight curvature to it. And the reason for that, I'll just tell you. Actually, if you want to pause the video and think about it for a second, go ahead. Okay, you paused the video, you've thought about it. The reason why this is not perfectly linear is because, of course, of air resistance. Okay, and on our y-axis, we have this nice parabola that looks a lot like it's due to gravitational acceleration, and it is. So, if we want to add error bars to either of these data points, what we will do is go ahead and click on the column. So we're going to click on the X column here and double click that guy, and then you'll go over to the Options tab. Okay. From the Options tab, we will tick Error Bar Calculations, and we're going to use one of our columns. Okay. The column that we want to use is X Uncertainty. Makes sense, right? So we click X Uncertainty using this pull-down menu, and when we hit Done, we will have our error bars. And you'll note that our error bars do kind of change over time. And I did notice as I was clicking through here that the x-axis was a little more unpredictable than what happens on the y-axis. Okay, so let's do the same thing for the y-axis. We will double click on this column, and click Options again. Error bar calculations, tick it on. And for this column, we're going to use our Y uncertainty. And when we click Done, we'll get these nice error bars. And from here, you can kind of arrange the graph however you want. So for example, if I want to get rid of that x-axis and just focus on my nice y values and that parabola, there you go, there it is. And there are my error bars, and they look great. From here, you could do things like fit a curve. So for example, if I click on this thing right here, I can add a curve fit. Here we would expect a quadratic relationship. So tick on that. And if we try a fit, yeah, we should see our coefficient here for our first term is -4.673. For gravitational acceleration, we would expect something around -4.9. So this is looking pretty good. And there's our curve fit. So nice. All right, we're going to leave it there. There are your error bars for an imperfect video. We've now analyzed our projectile motion with Logger Pro and uncertainty, and we even threw a nice curve fit just for funsies. Okay, so this is Mr. Van Lo's poorly monetized low-budget science channel. I hope you enjoyed the video. Do not click like, do not click subscribe. Just go forth and have a great day.